The Intramercurial Planets. Camille Flammarion. Popular Science Monthly. Volume 14. Pages 714 through 721. 1879. A good deal of noise was made a few months ago about a discovery that an American astronomer believed he had made during the recent solar eclipse of July 29, 1878. At the moment of totality, while the bright disk of the sun was completely hidden by the black disk of the moon, and after the eye had become habituated to this sudden darkness, the American astronomer made a search to find whether there might not be, in the vicinity of the sun, a planet answering to the theoretical planet Vulcan, whose existence was announced by Leverrier after he had mathematically analyzed the motion of Mercury. As everyone knows, during total eclipses of the sun, our atmosphere being no longer illumined, night comes on as though at the bidding of an enchanter, and the brighter stars make their appearance in the heavens. It is this sudden metamorphosis of nature that most forcibly impresses primitive races. It was this which, on the occasion of the earliest eclipse recorded in history, the eclipse of Thales, put a stop to the famous war of the Medes and the Persians, by sending the chill of mortal terror into the hearts of the warriors as they were on the point of engaging in battle. This it was which, at the last eclipse, led a Negro, suddenly frenzied and convinced that a deluge was about to be sent down by an angered deity, to strangle his own wife and children. Finally, it is this same feature of the solar eclipse which makes the deepest impression on the mind of the astronomer, who has made all his preparations for observation, but is so full of emotion in view of the grandeur of the spectacle, that he can only with difficulty analyze with his wonted coolness, and during the few minutes of total darkness, the details of the phenomenon. The American astronomer Professor Watson, the discoverer of a great number of small planets, has declared that his one thought during the recent eclipse was to look for the Intramercurial planet. In announcing this observation to the Academy of Sciences, the director of the Paris Observatory, Mouchez, expressed himself thus: "The accomplished astronomer of Ann Arbor has seen a heavenly body of the fourth magnitude, situated 2 degrees distant from the sun, and whose position was right ascension 8 hours 26 minutes, declination north 18 degrees 0 minutes. The star nearest to this position is Theta Cancri, 8 hours 24 minutes and 18 degrees 30 minutes, and it is of the 5th magnitude. This difference of magnitude and of position justifies us in supposing that in all probability it was the planet Vulcan which was again seen by Mr. Watson. The Academy cannot but receive with great pleasure this observation, which is only a new tribute to the scientific glory of Leverrier. Guyot has calculated an orbit and an ephemeris. The time of revolution is only 24 days. The planet is at its greatest distance from the sun today, August 5th. Tomorrow it will be at 38 minutes of time. This distance is great enough to allow of our observing it, if not at Paris, at least at other more favored localities." Watson's own account of the observation is as follows: "At the recent total eclipse of the sun, I was occupied exclusively in a search for any intramercurial planet which might be visible. For this purpose I employed an excellent 4-inch refractor, by Alban Clark & Sons, mounted equatorially with a magnifying power of 45. There were no circles originally attached to the instrument, and accordingly I placed it on circles of hard wood, the declination circle being 5 inches, and the hour circle 4 3/4 inches in diameter. On these I pasted circles of cardboard, and pointers were provided so that I could mark with a sharp pencil the position corresponding to any particular pointing of the instrument. This method does not compare in accuracy with graded circles and verniers, but it has the advantage, and a very important one in the present case, of avoiding the uncertainty which might be attributed to erroneous readings of the circles. To read the divided circles would require considerable time, while the pointings can be marked on the paper discs in a few moments. And besides, while a doubt might be raised as to the correctness of the recorded circle readings, no such doubt can exist in reference to the positions marked on these paper circles. The chronometer times corresponding to each pointing were recorded, and the designation of the object observed was also marked on the paper discs, so that there is no difficulty in identifying the several marks." He then goes on to give the particulars of his sweeps over the regions east and west of the sun, which were without result till, at last, between the sun and Theta Cancri, I came across a star estimated at the time to be of 4½ magnitude, which shone with a ruddy light, and certainly had a larger disk than the spurious disk of a star. The focus of the eyepiece had been carefully adjusted beforehand and securely clamped, and the definition was excellent. I proceeded, therefore, to mark its position on the paper circles, and to record the time of observation. It was designated by A. The place of the sun had been recorded a few minutes previously and marked S1. Placing my eye again at the telescope, I assured myself that it had not been disturbed and proceeded with the search. I noticed particularly that the object in question did not present any elongation such as would be probable were it a comet in that position. This body he holds to be Leverrier's Intramercurial planet. Its place is given as follows: 8 hours, 26 minutes, 24 seconds. Declination, 18 degrees, 16 minutes. It will be seen that this position differs from that given above, the declination being here 18 degrees 16 minutes instead of 18 degrees 0 minutes. On August 23rd, the observer added a new correction. In consequence of having employed an inexact value for the correction of the chronometer, an error has crept into the results. The true position is this: right ascension 8 hours 27 minutes 25 seconds, declination 18 degrees 16 minutes. Here we have a fresh difference in the first figure. The result is, first, that the orbit calculated immediately upon receipt of the telegram was made too hastily and on an insufficient basis. According to the American Observer, the definitive differences between the planet and the sun were, in right ascension, 8 minutes 21 seconds, in declination, 0 degrees 22 minutes. But in this same letter of August 23rd, he announces that he observed another star, also of the fourth magnitude, which presented the following differences from the sun. In right ascension, 27 minutes 18 seconds. In declination, 0 degrees 35 minutes. Whence results for this second star the position, right ascension, 8 hours 8 minutes 38 seconds. Declination, 18 degrees 3 minutes. A fourth datum sent to the London Royal Astronomical Society again corrects these positions as follow: 8 hours 27 minutes 24 seconds. 18 degrees 16 minutes. 8 hours, 9 minutes, 24 seconds, 18 degrees, 3 minutes. We will remind our readers that the right ascension of a star is its distance east or west from the first point of Aries, measured along the celestial equator, and its declination is its distance above or below that equator. They are the longitudes and latitudes of the heavens, corresponding to those of Earth, and they serve to determine the positions of stars as Earth longitudes and latitudes serve to fix in geography the exact positions of cities. And now comes another American astronomer, Mr. Swift, who also announces that during the same total eclipse he observed simultaneously in the field of his telescope 2 stars, of which the one was Theta Cancri, and the other a planet shining with the luster of a star of the 5th magnitude, and whose position he estimates approximately to be right ascension 8 hours 26 minutes 40 seconds, declination 18 degrees 30 minutes 35 seconds, a position very near to that of the star seen and determined by Mr. Watson. The eclipse of July 29th last, one of the most remarkable of the present century for the duration of totality, was observed all along the zone of centrality, which passed across North America, by a great number of able astronomers, both American and English. Nearly all of these searched for a new star in the neighborhood of the sun, but, with the exception of the 2 named above, all declare that they saw nothing beyond the stars rendered momentarily visible by the obscuration of the sun's light. Are we thence to conclude that the testimony of these 2 observers must be rejected? By no means. But between this and the conclusion that the 2 stars signalized by Watson are in fact 2 planets traveling between Mercury and the sun is a long way. Of these 2 stars, the second, it is supposed, cannot be the star Zeta Cancri, whose position is 8 hours, 5 minutes, 12 seconds, and 18 degrees, 2 minutes. The difference of 3 minutes is no doubt very great, but when we take account of the haste of observation, and the doubt expressed by the observer himself with regard to its exactness and the possible derangement of his telescope by the action of the wind, this star must not be dismissed without seeing whether or not it will explain the observations. Now, supposing an error of 3 minutes more or less, the position of the first star becomes 8 hours, 24 minutes, and 18 degrees, 16 minutes, and this is very nearly the position of the star Theta Cancri. All that is needed to show how probable is this explanation is to take up a celestial atlas and to locate the sun at the point where it was at the moment of the eclipse, that is, in front of Delta Cancri, which was visible through the aureolar corona of the eclipsed sun at its eastern margin. We have reproduced in the figure the aspect of the heavens during totality. Figure not reproduced. 1 is Mercury, 2 is Regulus, 3 is Mars, 4 is the sun in eclipse, 5 is Procyon, 6 is Pollux, 7 is Castor, 8 is Venus. In the immediate vicinity of the Sun, we have inserted at the points A, B, C, the 3 stars Delta, Theta, and Zeta Cancri. In our opinion, the 2 stars B and C are the ones which might have been taken for 2 planets by the American observers. No doubt this hypothesis is a rather bold one, but then the hastiness, the difficulty, and the vagueness of the observation justify it. Mr. Watson did not announce his observation of the second star till 3 weeks after the eclipse, and after he had revised in detail the conditions of his observation. Here is proof that the star had made a less impression on him than the first, but now the first is between the 4th and 5th magnitudes, and the second only between the 5th and 6th. In any case, we cannot but hold that the positions given are highly doubtful, and cannot be seriously assumed as a basis for calculating orbits, as has been done at the observatory. Mr. Swift writes, "I have no doubt that one of the 2 stars was Theta Cancri, and the other the Intramercurial planet. But if one of the 2 stars seen by Professor Watson is Theta Cancri, the other, whose difference from the former is, according to him, 18 minutes 57 seconds more to the west and 13 minutes more to the south, comes exceedingly near to Zeta Cancri, whose difference from Theta is 19 minutes 25 seconds also to the west and 30 minutes also to the south. If this star were a planet, it would not have been possible to see it without at the same time seeing Zeta, which would have been quite near. But of Zeta our American astronomers do not speak." Mr. Swift, however, answers this objection by saying that he saw simultaneously Theta and the planet, and states the difference between them as follows. Star Theta, 8 hours 24 minutes 40 seconds, 18 degrees 30 minutes 20 seconds. Planet, 8 hours 26 minutes 40 seconds, 18 degrees 30 minutes 25 seconds. The 2 stars appeared red to him, shining at 3 degrees southwest of the Sun, and presenting large disks of the 5th magnitude. He adds that he saw no other star, not even Delta, and that the distance between them was from 7 minutes to 8 minutes of arc. Nature, September 19, 1878. The 2 stars seen by Swift, then, are not the same 2 seen by Watson. The matter is a good deal confused. Further, in observing the star Zeta Cancri, 2 stars could have been seen instead of 1, for Zeta is a double star. It is, indeed, a triple star, but a high power is required to see it triple, whereas a moderate power easily shows it double. But, inasmuch as only very low powers were employed, it is probable that no new cause of perplexity exists here. To sum up, while it is possible that the American observers saw an intramercurial planet, or even 2, we cannot, in view of the special difficulties of the situation, the confusion of the figures, and the negative observations of the other observers, concede it to be an absolute and incontestable fact that they even saw so much as 1. The fact is not yet certain. We would remark that no variable star is known to exist at that part of the heaven. Might it not be a comet? It did not present the characteristics of a comet. Whatever the upshot may be, this discussion goes to show that in astronomy, nothing is accepted without being first verified, and that this science is becoming more and more worthy of its reputation of being the exactest and the most absolute form of human knowledge. This strange vicinage of the Sun is unfortunate indeed in the annals of astronomy. Time and again have observers supposed that they saw planets passing before the Sun, and, out of all the observations which have been made, there is not one which definitively settles the question. The penultimate astronomical observation announced as appertaining to an intramercurial planet was that of the German astronomer Weber, who was presented to Leverrier by Wolf, of Zurich, as having been made on April 4, 1876, at Pecolo. A small, well-rounded disk of 12 seconds of arc appeared suddenly during a partial clearness of the sky, éclaircie, which was turned to account for observing the Sun. It was impossible to pursue the observation owing to clouds. Wolf calculated that this observation accorded with 2 prior observations made in 1859 and in 1820, and fixed the period of the planet at 42 days. Leverrier, too, seemed disposed to accept this observation, which gave occasion for a new memoir by the illustrious French astronomer, in which he brought together and compared all the observations of this kind. The stir which this made in the scientific periodicals is still remembered, but yet the little black spot observed by Weber was not a planet at all, but merely a sunspot, round and without penumbra. It had been observed 5 hours earlier at the Observatory of Madrid and at the Observatory of Greenwich, and it was easy to prove that it was nothing but a simple sunspot. The fact that the spot was not to be seen the next day seemed to confirm the planetary hypothesis, but it was not sufficient, since there are ephemeral sunspots too, nor is the roundness of the spot a distinctive character either. The proper movement then remains. Here we must note a circumstance which oftentimes must have caused illusions. When we observe the sun with a telescope not equatorially mounted, and whose support has not the two motions, vertical and azimuthal, as is commonly the case, the position of a sunspot, by reason of the diurnal motion, is ever changing with relation to the vertical diameter of the disk. Even when an observer has had large experience, it is difficult for him to guard against the belief that the spot has changed its position on the disk. This observation, then, had to be disallowed, but there remained others which were not to be discredited on the same grounds, and Leverrier, taking them to be more trustworthy, used them in calculating the orbit of the hypothetical planet. Different interpretations gave him 5 different orbits, with periods varying between 24 and 51 days. But he seems to have preferred that which gives a period of 33 days, and announced that on March 22, 1877, the planet in question might pass before the sun. Astronomers all over the world, with one accord, observed the sun on that day, to descry the transit, but the result was nil. No black spot was to be seen. Among the prior observations, Leverrier accepts 5 as certain, viz., Fritzsche's in 1802, Stark's in 1819, Cuppus's in 1839, Sidebotham's in 1849, Lescarbot's in 1859, Loomis's in 1862. One of the best is no doubt that of Dr. Lescarbot, a country doctor, with a passion for astronomy, and who had vowed to the study of the heavens the time which was not spent in alleviating the wretchedness of earth. This amateur astronomer, while observing the sun on March 26, 1859, from his humble house at Orgeres, discovered on its radiant disk a round, very black spot, which he was able to study for over an hour, and the proper motion of which he thus determined, no doubt taking account of the causes of error to which we have alluded. It was during this same year that Leverrier perceived the necessity of increasing by 38 seconds the secular movement of Mercury's perihelion, and offered the hypothesis that a planet nearer to the sun than Mercury would account for the difference. Thus the observation made by my old and learned friend came as though on purpose to confirm the theory, just as earlier the telescopic discovery of Neptune had come to confirm so brilliantly the theoretical discovery of that distant planet. Well nigh 20 years have passed since 1859, and yet a fact which one might have supposed would be speedily confirmed, owing to the rapidity of the planet's revolution, and no doubt frequent transits across the sun, this fact has received no confirmation. Yet search has been made for it throughout the whole region on both sides of the sun, if perchance it might be seen at the periods of its greatest distance. Perhaps not a day has passed for the last 20 years, but that the sun has been examined at one point or another of the globe, observed with the greatest care, sketched in all its details, even directly photographed. The hypothesis of a single body comparable to Mercury, gravitating in close proximity to the sun, and on a plane probably little inclined to the solar equator, seems to us to be so open to objections as to be untenable. Still, the mathematical theory of universal attraction proves that there is still a cause for the retardation observed in the motion of Mercury, and that this cause cannot be found by augmenting the mass of Venus, a quantity now determined with great exactitude, but must be sought for in some disturbing mass between Mercury and the sun. But this mass may not be a planet worthy of the name planet. It may consist of a great number of asteroids like the minute fragments which gravitate between Mars and Jupiter, asteroids so small that oftentimes they escape the notice of observers of the sun and of eclipses, though some of them may be large enough to be seen under certain rare conditions. This latter theory is the one which we adopt.